Hello everyone! In this video we're going to be continuing our discussion of functions by exploring a new type of function called pass-by-reference functions. And this all has to do with the particular values that we're passing in as parameters to our functions. We have pass-by-value, which we talked about in our last chapter, and pass-by-reference. So to get started, I want us to form a little bit of motivation for why we need pass-by-reference variables. So we're going to be building a program that simulates one battle in the game of Risk. So a lot of us have probably played Risk at least once or twice, and so we're going to simulate one of the battles. The attacker gets 2 rolls and the defender gets 2 rolls, and the attacker has to roll strictly better than the defender in order to defeat them. So we're going to build in the attacker rolls 1 and 2, the defender rolls 1 and 2, and some other variables that we're going to need in order to calculate how well the attacker is doing. Now rolling means rolling a value on a die, which we can simulate by generating a pseudo-random number between 1 and 6. So we're going to add some extra libraries so that we can use the pseudo-random number generator. And one of the things we're going to focus on in this example is reducing areas of redundancy. So we're going to create a roll function that will simulate the rolling of the die for us. So that our rolls will be set up with calls to the roll function. Now you may be noticing that this still seems like there's a lot of extra repetition, and there is. We could do this with a loop if we stored these values in an array instead of separate integers. But what we haven't yet talked about is how to pass an array to a function, so we'll do that later in this module. So we're going to print out these values so that after we've built the function that produces the simulated dice roll, we can check to see what the values are. So now we're ready to build our function. Since there's no parameter list, we know there are no preconditions, except that we assume that the random number generator has already been seeded, which we've already done in main, and we only have to seed the random number generator once. Our post condition is that we're going to return a pseudo-random value between 1 and 6. So we're going to create a random number. We're going to make sure there's only 6 possible numbers that it can be. And then we'll make sure that those numbers are from 1 to 6. So remember, modding by 6 is going to give us potential values 0 to 5. Adding 1 will get us values from 1 to 6. So now we're ready to run the program and make sure that we see some pseudo-random values between 1 and 6. And so we're going to see that the attacker has rolls 1 and 2, and the defender has rolls 1 and 6. So now, in order to check to see if the attacker is doing better, we need to put them in order. We need to compare the highest values from the attacker and the defender to each other. So we need to compare the attacker's best roll to the defender's best roll. So to do that, what we're going to do is put the best rolls for each player into the 1 spot. And the second best roll will obviously go to the 2 spot. So to do that, we need to check to see if the first roll is not the best one, make it the best one. So if the best roll isn't already in the 1 spot, then we need to put this value into here and this value over here. We need to swap them around. And swaps are a really common programming task. We have to exchange the values of 2 variables. We do this a lot in sorting, in this RISC program, and when we're inserting elements into abstract data types, which is something we'll talk a little bit about towards the end of the semester. So this is a really common thing that we do, which means we'd like to be able to build a function to do it for us. Here's the standard format for a swap if we're using integers. We have 2 integers, a and b, and we'd like to just swap locations. But we can't just set a equal to b, because then they would both be 3. So we also have this temp value. So temp will hold on to the value of a temporarily. Then a can take on the value of b, and then b will take on the value of temp. So since this is something we do so often, we'd like to build a program that will do that for us. So I'm using our blank test program to try and simulate the process. We're going to try and build a function and see if it works. We want to swap the value of 2 integers. So we're going to create a temporary value to hold on to the value of the first one for a while, set x equal to y, and then y equal to temp. So that should swap them places. And in main, we're going to print them out to see if it works. So we'll print the values of a and b originally, then we'll try and swap them, and then we'll print the values of a and b again to see if it worked. So as we can see from running the program, it doesn't work. And this is because swap, as we've currently created it, is called a pass-by-value function, meaning what we're passing to swap is just the values of a and b, not a and b themselves. In order for us to actually swap the values of a and b, we're going to need references. So here's a quick look at the definition of the two. In a pass-by-value function, the value of the variables is passed from function to function, so only the contents, not the variable itself. In a pass-by-reference function, the reference to a variable is going to be passed instead of the value. So we're passing the actual memory location, the reference of a variable, so that we can change things at the memory level. A common type of reference is called a pointer. A pointer is a variable that contains a memory address. So it does not contain a value in the traditional sense. An integer pointer does not store an integer. It stores a memory address where an integer is located. Similar story, if we have a float pointer, it doesn't store a float value. It stores a memory address that points to where a float is located in memory. Like when we did file pointers, that pointer that we created, that IFP for input file pointer, didn't store the whole file. It just pointed to where the file was in memory. So that's all pointers do. They point to locations in memory. So they store memory addresses. So to create a pointer, we're going to use something that is similar to what we did with files. We're going to start with a data type. So we can create pointers of any of our basic data types. We can create integer pointers, float pointers, double pointers, character pointers, and still file pointers. That data type's followed by an asterisk. This asterisk represents pointer. So if we did an integer pointer, it would be int pointer. And then we'll give it a name like any other variable that we would normally create. So here's an example. This is an integer pointer called p for pointer. Pointers are also initialized similar to regular variables. If we were to initialize a regular integer, we would just assign it an integer value. Well, pointers store memory addresses. So to initialize a pointer, we're going to assign it a memory address. And for that, we're using the ampersand. The ampersand can be thought of as saying the memory address of. So in this case, we're saying that p, the pointer, should be assigned the memory address of a. So let's do a quick visual of what's happening in these two lines. So we are creating an integer a, which we've assigned an initial value 7, and then we create an integer pointer p, which has the address of a. So when we declare an integer, the program will go out to its memory space and set aside enough space to hold an integer. And then it will label it with the integer's name. So that first line, integer a equal to 7, creates a box in memory sized big enough for an integer, which happens to be 32 bits, labels it a, and then stores 7 within the box. So this is our integer a with room for an integer, and we've currently stored the integer 7. Then we create p. Now p is a pointer, so it doesn't store an integer value itself. Instead, we give it the address of a. So what p does is it points to the box in memory where a is located. So this is what we've accomplished so far. We've created an integer a and stored 7 there. And we created a pointer p, which points at a because it's been assigned the memory address of a. We can now use p to manipulate a at the memory level. This is called dereferencing a pointer. We're going to use the asterisk to say go to where p is pointing. So instead of using the memory address, we're going to go to that location in memory and assign it the value 3. So go to where p is pointing and assign it the value 3. So we're going to go to where p is pointing and put a 3 there. So go to where p is pointing, dereference p, go to where p is pointing at this box, and put a 3 there, assign it the value 3. So we put a 3 there. So now if we were to print a, we would see 3 instead of 7 because 3 is what is stored in the box labeled a in memory. So now we can take a look at what that looks like in code. And we'll start just by doing the same simple example we just looked at. Here's integer a. It has the value 7. Here's integer pointer p that has the address of a. If we go to where p is pointing and put a 3 there, then a will change to 3. And of course we can demonstrate that just using some simple print statements. See, when we started out, a started with an initial value of 7. We created a pointer p that pointed to a. When we printed it out here, we haven't changed anything yet, so we're going to see the initial value, which is 7. Then we use p to go to where p is pointing, which is pointing at a in memory, and put a 3 there, so that the next time we print out a, we see 3 instead. Now, this is going to be really useful for our swap function. Instead of swapping two integers, we're going to swap the contents at memory pointed to by these two pointers x and y. So instead of having integer parameters are integer pointers, and we want temp to be assigned the value that x is pointing at. We want what x is pointing at to have the value that y is pointing at, and we want what y is pointing at to have the value in temp, so that these values get swapped at the memory level. And there's one more thing to modify, and that is our function call, because we know in order to have a valid function call, this parameter has to be of the same type as this parameter. So right now this one's an integer and this is an integer pointer, so they're not the same thing. What's compatible with integer pointers is other integer pointers and memory addresses that go to integers. So when we call the swap function, we're going to give it the address of a and the address of b. So this time when we call swap, because the changes are happening at the memory level, we're able to actually swap the values of a and b. So let's take an in-depth look at what's going on. In our memory space, we have these variables a and b. They've been created in main. A has 3, b has 7. So in our program's memory, we have two integers. One's labeled a, one's labeled b. A has the value 3 in it, b has the value 7 in it. And then we call swap with the address of a and the address of b. So in our swap function, we have these pointers x and y. So we have x, which is a pointer, and since we've called it in this order, x has the value of the address of a. So x will be pointing at a. Y, which is our second parameter, y takes on the value of the address of b. So y will be pointing at b. So inside our swap function, we have these two local variables, pointer x, pointer y. X points at a in main, y points at b in main. So x is pointing at a and y is pointing at b. Inside our swap function, we create another value called temp. So we'll go to our memory space and create another box for this integer, and this one will be called temp. We say that temp should be assigned the value that is pointed to by x. So go to where x is pointing and get 3. So we'll put this value 3 in temp. So at the moment, we have 3 integers and 2 of them are equal to 3. Then we say, go to where x is pointing and assign it the value that y is pointing at. So go to where x is pointing and put here the value that y is pointing at. So we're going to go to where x is pointing in memory and put a 7 there. So now 2 of our variables are equal to 7. Then go to where y is pointing and put there the value in temp. So go to where y is pointing and put the value of temp there. So that's how we swap the values of a and b using our swap function with pass-by-reference parameters. So now we're ready to take this and apply it to our RISC program. Remember, one of the benefits of making functions is reuse. So we've already built this function, so we don't have to rebuild it. We can just have it for our new program. The parameters are pointers to integer values, and the goal of our function is to swap the contents of x and y. So if our roles are not in order, then we want to swap them around. So we'll pass to swap the addresses of our roles. And we'll do the same thing for the defender. If their best role is not in the first location, then we should swap them around by passing each role to the swap function using a reference. So now we can figure out how many armies the attacker is defeating. So we'll build an attack function. We need to pass in the 4 dice rolls, each of which is an integer, so 2 from the attacker, 2 from the defender, and check to see if A1 is better than D1 and A2 is better than D2. So compare the 2 best rolls and then compare the 2 worst rolls. So we are assuming that they're already placed in order. Our function's not going to check for that. A represents the attacker, D represents the defender. So from the attacker and from the defender, and we assume they are in order. And for our post condition, we're going to return the number of armies the attacker defeated. So we'll start off with 0 armies because we haven't checked any values yet. Start off with 0. If A1 is better than D1, then that'll be 1 army. If A2 is better than D2, then that'll be another army. The most they can defeat is 2, so that we're going to return in an answer that is 0, 1, or 2. And we'll pass that back. We'll return that value to the main function. So when we call that function, we're going to call after we've placed them in order. Attacker roll 1, attacker roll 2, defender roll 1, and defender roll 2. And then we can print the results. Okay, so now we can test our final version of the RISC program. Doesn't require any user input, so we can just observe a couple of runs. The attacker rolls 2 and 2, the defender rolls 4 and 3, so neither of these values from the attacker are better than the defender rolls, so they defeat 0 armies. In this case, 6 and 6 are both better than 3 and 2, so they defeat 2 armies. Here's one where the attacker only defeats 1 army. We have to place these values in order so that we compare 6 and 6 and 5 and 6, and only strictly better wins. So only the 6 beating the 5 counts. That's why it's only 1 army. So now we have 2 different types of functions that we can consider. We have pass-by-value functions and pass-by-reference functions. It's easy to tell them apart when you look at their parameter lists. A pass-by-reference function is going to have a reference in the parameter list. So this one is a pass-by-reference function because these integer pointers are references. So a reference is a pointer or an array. The name of an array is also a pointer, so an array is automatically a reference. A function that does not have any references in the parameter list is a pass-by-value function. So this function, this attack function, is a pass-by-value function. It has no references in the parameter list. We could change the values of A1, A2, D1, and D2, and it would have no effect on the corresponding parameters in main. They wouldn't change at all. Whereas any modifications we make to what X is pointing at, those changes are going to be evident everywhere because we've made those changes at the memory level. In our next video, we'll do some examples of programs that have functions with pass-by-reference variables to further demonstrate this topic. I'll see you then.